So this is take 2 of notes today. So f of x is the output of the function, and x is the inputs. So x is what we usually put into the function. F of x is what we take out. Okay? So think of a function kind of like a machine. You put something in it, and it creates something, and something else comes out. When I was in college, I worked with my dad's company in the summertime, and it's Kimberly-Clark in Corinth, Mississippi. And Kimberly-Clark makes a lot of like Kleenex tissues, diapers, things like that. So, like the machine I worked on was 4 stories high, literally. And it would start out with little bitty tiny plastic pellets, tinier than BBs. All right. And there was these chutes that would shoot these little BBs into the machine. And then at the end was like rolls and rolls of paper. That's what it would create, like rolls the size of this room of paper. They would weigh more than cars. All right. So, yeah. So think of a function like a machine. You put something in, something comes out. All right. You put X values in, Y values come out, basically. All right. So, for example, if f of x equals 4x minus 1, the same example they have there, find f of negative 7. Well, where is the negative 7 at? It's where the x was in parentheses, right? So if it's in the x spot, that means we plug negative 7 in for all of our x's. So whatever's in parentheses is what you're going to plug in for x. So you're going to say f of negative 7 equals 4 times negative 7 minus 1. Okay? And then you do order of operations. We multiply before we subtract. What's 4 times negative 7? Negative 28 minus 1 is negative 29. So f of negative 7 is negative 29. That means when the x value for this function is negative 7, the y value is negative 29. Okay, so negative 7 comma negative 29 is an ordered pair that falls on this line, since this is a linear function.
So that's it.
That's it. Yeah.
So do we have to write it in the ordered pair form?
No, because we're in function notation. Function notation, you leave it like this. All right. So let's just do some examples. F of x equals x plus 7. That's a semicolon there, okay? And they're telling us to find f at 5. So what do you think we do? Plug 5 in for all your x's. So we're finding f of 5 equals 5 plus 7. And what's 5 plus 7? So f of 5 equals 12. Okay? And this is the same thing as the ordered pair, 5, 12. But since we're doing function notation, that's the acceptable answer. Does that make sense? So what comes after the equal sign is your final y value, basically.
Can we keep it as...
Do what? Keep it like this. I'm just telling you, this is the same thing. But keep it as this because we're in function notation. All right, the next one we call this function g. Okay? Don't freak out that it's a g instead of an f there. We just call it g of x instead of f of x. Okay? It's just the name of the function. All right, so g of x equals 3x minus 8. We want to find g of negative 3. So how do we do that? Yeah, so g of negative 3 equals 3 times negative 3 minus 8. And what's 3 times negative 3? Negative 9 minus 8 is negative 17. So g of negative 3 is negative 17. That's it. It ain't. You're just plugging it in. You're doing what you did yesterday. It's just looking a little different. Yeah. All right. So this function is called h. H of x equals 2/3 x minus 1. And we want to find h of 9. So how do we do that? Plug 9 in for all my x's. So h of 9 equals 2/3 times 9 minus 1. Multiply first. What's 2/3 times 9? 8. No. 18 divided by 3, which is 6. And 6 minus 1 is 5. So h of 9 equals 5. All right. What's different about number 4 here? They put us an exponent in there. That means this is no longer a linear function. It's actually called a quadratic function because of those U-shaped graphs that we've seen, those parabolas, that's what this is going to be, okay? But we're not going to worry about that right now because we're not graphing today. We're just plugging in, getting function values. So everywhere there's an x, I'm going to plug in a -4. Now, I'm going to use parentheses where I plug in because if not, you might mess up on your signs. So please use parentheses everywhere you plug it in. Y'all see that? It's x squared minus x. Okay? Now, y'all, do y'all know that calculators are not always correct? If you just type in -4 squared in your calculator, it's going to tell you -16, and that is wrong. What is -4 squared? 16. Positive squared. Is the negative squared ever going to be a negative? No. So you have to know that. You have to know a negative times a negative is a positive before you use a calculator, right? Or you're going to get things wrong. All right? So you need to know that -4 squared is positive 16. And that's minus -4, which changes to what? Plus 4. So you've got to know your sign rules, okay? And then what is 16 plus 4? 20. So when f is negative, well, f of -4, which means when the x value is -4, the y value is 20. Okay, so far? Number 5 is one we really need to be careful of, is when we have a negative outside our x squared. Okay, so what are we plugging in for x? 5. So f of 5 equals, okay, what does that mean, -x squared? It's -1 times x squared. -1 times x squared. And I'm putting x or 5 for all my x's there. I've got 3 terms in that one.
So it's -x.
You always put in times -1. Yes. Because here's the thing. I'm going to go over to the side over here. If I do this, that's a positive 25.
Yes.
Right? But if I do this, order of operation says I square before I multiply, right?
And then
Exponents before we multiply. So that's -1 times 25, which is -25. This one's right, this one's wrong. Got it? Got it? Okay. So you're not squaring -5, you're squaring 5 and then multiplying times -1. Does that make sense? So be very careful about your signs. That should be a -25. Stop hitting everything. I'll get used to this touch screen one day. And then what's 6 times 5? 30. And then -4. So it's -25 plus 30 minus 4. Just go left to right. -25 plus 30 is what? 5 minus 4 is 1. So this function, when f is at 5, y value is 1.
So we don't have to put F5 every.
I know, as long as you put it with the answer, I'm good. Yeah, it just gets a little messy looking sometimes if you keep on going with it. If you do it, it's technically mathematically more correct to do that, but if you drop it down and put it with the answer, I'm good. I want you guys.
On the -1, you don't like bring it with the one.
I did it in my head. Order of operation. 5 squared is 25 times -1 is -25.
So you don't care if we do.
No, as long as you get it right.
I'm making sure.
As long as you get it right. As long as you know you square before you multiply. Alright? Alright, I want you guys to try number 6 and number 7. Number 6 and number 7.
If you are ready to turn in your homework, make sure your name is on it and pass it.
Watch your signs.
was about to say, I know I've done as well.
You don't know the way.
Okay. I'm gonna let finish it.
You're saying it well because then.
Thanks, babe. What? I was at I'm gonna finish it, and we put on. What do these fish camps have to do with that? Okay. Put on the last time I do. I know one night. Tell everybody off. Here we go. No. Factor completely. Factor completely.
Don't do me. This is basic math.
Factor completely.
Add, subtract, multiplying, and squaring. That's all you're doing, right? You're not even dividing.
Still a little confusing with so many negatives that are.
Negatives are a sixth grade problem. Well, then you should practice more in sixth grade. All right. So, y'all help me. I already plugged in my -8 for number 6. What's -1/2 times -8? +4, and then 4 plus 9 is 13. Raise your hand if you got g of -8 equals 13 on number 6. Any questions there? All right. So on number 7, I plugged in -5 for all of my x's. And order of operations. What do I do first? The exponent. What's -5 squared? 25. So this is, I don't care if you showed this step or not, but I want to right here. 2 times 25 is what? 50. Right? And then we'll keep going. 4 times -5 is what? -20. And then -9. Right? Okay, so I got 50 there. -5 squared is 25. 2 times 20. You square before you multiply. Please excuse comes before my dear. Okay? All right. So 50 minus 20 is what? 30 minus 9 is what? 21. Raise your hand if you got F of next. My touch screen is extra touchy today. Extra touchy. What am I doing? 21, F of -5. Raise your hand again. Let me see. Who got that right? Awesome. Okay, let's see if I can do something here. Hang on, my friends. Draw with touch. Let me see. Ooh, ooh, ooh. Do. Maybe they'll make it a little less crazy. Maybe not. All right. What's different about number 8 here? It's got absolute value bars, okay? So what we're going to do is we're basically going to plug in that -7 for those x's. And then we're going to evaluate the absolute value bars at the very end, okay? So we're just going to keep them going down the whole time and evaluate them at the very end. So g of -7 equals the absolute value, I'm going to use parentheses so I don't mess up my signs, minus -7 squared. So use parentheses so you don't mess up your signs. And inside the bars, you also need to apply the order of operations. All right, so we're going to do order of operations inside the bars. So order of operations inside the bars, do we exponent first or do we subtract first? Y'all need to be looking up here. Exponent first. All right, so what is -7 squared? +49, but since there's a minus outside it, it's still going to be -49. Y'all see that? So the absolute value of -7 minus 49. And what's -7 minus 49? Yep. So the absolute value of -56. So the final answer is what? G of -7 equals +56. You okay with that? Okay. Skip number 9 and number 10. Skip down to number 11. This is when it gets a little bit more challenging. All right, look down here at these. Do you see how there's a box over to the left? Right? How many functions are in the box? 3. One's called F, one's called G, one's called H. Right? Y'all see them? Okay. So it says to find, number 11 says find the function of f of 4 and then add 9. Okay? I want you to ignore the add 9 for a second. Okay? First, we're going to find f of 4. So obviously, if we're finding f of 4, what function are we going to use? I'm going to use f. Does that make sense? Whatever letter it has outside the function, that's the function you're going to use. So that's the first thing I need to do is find f of 4. So that's going to be 8 minus 3 times 4, right? What's 3 times 4? 12. Oh, sorry. It's supposed to be 8 minus 12. And what's 8 minus 12? Negative 4. So f of 4 is negative 4, right? But I'm supposed to find f of 4 plus 9. Well, f of 4 is negative 4, so f of 4 plus 9 is going to be negative 4 plus 9. Y'all see that? This right here is negative 4. I worked that part out. Right? So I can replace this with negative 4. So negative 4 plus 9 will get me my final answer. And what is negative 4 plus 9? 5. Final answer. Okay? Yep. That's all you got to do. So find the function it asks you to find, the function value it asks you to find, and then plug it into that expression. Okay? So number 12 says to find negative 2 times g of negative 5. So what do you think we need to do first? Find g of negative 5. So that's what I'm going to do first. G of negative 5. So I'm going to use g now. G says x squared plus 2x. So I'm going to say negative 5 squared plus 2 times negative 5. Order of operations. What's negative 5 squared? Positive 25. And what's what's 2 times negative 5? Negative 10. And what's 25 minus 10? 15. So g of negative 5 equals 15. Plug that into the original. So that's going to be negative 2 times g of negative 5, we just said was 15. And what's negative 2 times 15? Negative 30. Final answer. Y'all see how I did that? Plug in where you got to plug in and then substitute for that number. Now that we knew what g of negative 5 was, it's just the number 15. You just multiply negative 2 times 15. Does that make sense? So you just plug in and then plug in again, basically. All right. Number 13 looks a little different. Right? 13, we got to plug in 2 of them, don't we? Right? We first got to find g of 4 and then g of negative 1, and then you add them together. Y'all see that? Okay, so let's do it. G of 4. So that's going to be 4 squared plus 2 times 4, right? Put 4 in for all my x's. So what's 4 squared? 16. What is 2 times 4? 8. And what's 16 plus 8? 24? 24? So g of 4 is 24. I also need to find g of negative 1. I'll just come over here. So that's going to be negative 1 squared minus 2 times negative 1. I need space. Try it again. Stop. G of negative 1 equals negative 1 squared plus 2 times negative 1. All right, what's negative 1 squared? What's negative 1 squared? 1. And 2 times negative 1 is, and what's 1 minus 2? Negative 1. So g of negative 1 is negative 1. Well, it said in the original to add those two numbers, right? So g of 4 is 24 plus g of negative 1 is negative 1. What is 24 plus negative 1? 23. So 23 is the final answer. Does that make sense? Solve them separately. So you're basically doing what we just did earlier. You're just combining them at the end somehow. All right? Because this is just a number. G of 4 is just a number. It was 24. G of -1 is just a number. Then you just add those two numbers. Okay? So you got to get past, oh, there's a variables. No, it's not. That's a number and that's a number. Okay? You see what I'm saying? Okay. 14 is a little complicated. Right? It's 3 times h of 2 minus f of -9. So what do you think I need to do first? I need to find h of 2 and then I need to find f of -9, right? And then I'll put them together. Okay. So h of 2, and we're going to use what function for h? The bottom one. Equals -5 over 2 times 2 minus 1. And I'm not freaking out because didn't I teach you a little trick yesterday at the top or the big and the bottom? Yeah, they'll cancel out. So that's -5 minus 1. And what's -5 minus 1? So h of 2 is -6. Okay. Now I need to find f of -9. So that goes into the f equation. 8 minus 3 times -9. What's -3 times -9? Positive 27, right? So that's 8 plus 27. What's 8 plus 27? 35. So any questions about how I found those two? Okay, let me get a blue pen real quick. All right, so I'm going to plug those numbers into that original. 3 times h of 2. So 3 times, what did I get for h of 2? -6 minus f of 9, or f of -9. What did I get for f of -9? 35. Y'all see that? That's a number, that's a number. Now plug them in. Does that make sense? What are you not getting? Well, h of 2 is a number. I already did that. I plugged 2 in for h and got -6. Okay. To the original. 3 dot h of 2. That means 3 times h of 2.
So it should be 3 times -6.
And then minus f of -9, which is 35. So it's like these are variables that you're plugging in. Does that make sense? This is a number we already found out it's -6. This is a number we already found out is 35. 3 times that number minus that number. Does that make sense? Is that better? Is that clearer? Okay. Now we just do the arithmetic. What's 3 times -6? -18 minus 35 equals what number? It's -53. Final answer. Okay. So I know it's kind of hard because it's kind of jumbled up, and I apologize for that. But you just plug each one in, and then those are just numbers, and then you plug those numbers. It's like it's in a new formula here. Does that make sense? Okay. 3 times what I got for h of 2, which is -6, minus what I got for f of -5, which was 35. Does that make sense? All right. 15 is a little bit different. 15 and 16 both. Do y'all see what's different about them? How it's worded? Because this is important. Yeah. When they give you a number in the parentheses, they're giving you the x value to plug in. Y'all see that? Everybody needs to see the difference. See, like over here where they said G of 4, that means I plug 4 in for my x's, right? Because 4 was in the x spot. Okay? So this time they tell you the function equals -13. Find x. You plug it in for where y would go. So you plug it into where f of x is. Does that make sense? So, yeah, so -13 is your solution. You're finding x, so you're working backwards. Y'all with me? So wherever this says, you plug in, can you see up here in the box for that? Okay, so our equation is going to be negative 13. Just if I could quit erasing myself, equals 8 minus 3x. And then you just solve it for x. So these are the, y'all say that? Okay, so f of x equals negative 13.
Oh, okay.
So negative 13 goes in the f of x spot for that equation. Does that make sense? Y'all are just not used to seeing two variables squished together or something, right? Okay, it's just the name of the function. It can't help it the same as f of x, right? Some of y'all have double names. It's okay. My mama called me Amanda Beth my whole life. All right? Most of the time when she was mad at me, which was a lot. All right? Y'all see what I'm saying though? Okay. So, how do I solve this for x? Yeah, we're solving for x. So what do I need to do? Good. Subtract 8. What's negative 13 minus 8? Equals negative 3x, and then what? Divide by negative 3, and x equals what? 7. Okay? So, you just got to read what the problem is saying. If it says find x, you're going to plug that number to the left. Does that make sense? That number's going to go as the name of the function. So, y'all tell me how I'm going to set up h of x equals 39. 39 goes in for h of x right there, right? So, I write what equation? X minus 1. Y'all see what I did there? Y'all see what I did there? Okay? It says those two equal, so I can replace h of x right here with the 39. Okay? And now solve the equation for x. How do I do that? Add the 1. What's 39 plus 1? So 40 equals negative 5 over 2x. How do I get rid of a fraction times my variable? Multiply by the reciprocal. What's the reciprocal of negative 5 over 2? Yeah, negative 2 over 5. Good. So those cancel over there. Put 40 over 1. I can reduce diagonally, can I? 5 and 40? 1 and 8. 1 and 8, yeah. And your final answer is what? Negative 16. You're good. You're good. Y'all see how we did that? Basic equation. Basic equation. All right. We got a word problem next, right? Let's see if I can get the whole thing on my screen. Anthropologists. Y'all know what an anthropologist does? Those are people that are around digging for dinosaur bones and things like that. Use the length of certain bones of the human skeleton to estimate the height of a living person. Of the living person. Okay, so I guess they dig up the dead person and measure the bones and see how tall the person was when they were alive. Okay. Do what? It is. Okay, so they might not find all their bones. Right? But think about like a war. Right? A civil, like, you know, you go to Shiloh, Civil War. Yeah, exactly. So they might just find one bone. Okay? So there's a formula to kind of estimate how tall a person is, and that can kind of verify like what remains went to what body. Right? I did. So it can, yeah. I mean, why do you think we put our height on our driver's license? I mean, it's kind of morbid, but you know, things like that. Okay, so it just helps ideas. So to estimate the height in centimeters of a female with a femur, y'all know what the femur is?
This big old
The big leg bone, right? Right from hip to knee. All right. The height of a female with a femur length of x, the function is, there's actually a formula for it. 61.41 plus 2.32 can be used. Okay, so they're finding a femur of 46 inches and explain its meaning. Okay, so what do we need to do to find h of 46? Plug it in, right? And I'm going to use my calculator to help me because we have decimals and such. So where they have an X, we're going to plug in 46. So mathematically, order of operations, what do we have to do first? So 2.32 times 46. What are y'all getting? Me too. Now think about, these are centimeters, not inches or feet, okay? So, yeah, you got to wake it up. And then we're going to add 61.41 to it. And what do y'all get? 168.13 centimeters. So if a lady had a femur that was 46 centimeters long, then she was estimated to be 168.13 centimeters tall. Okay? So that's kind of how that means. I don't know. You'll have to do the conversion from centimeters to inches and then inches to feet. I'm not doing it today. I'll get to that in a second. All right. Okay. There you are. Now, y'all, now we're getting down some important stuff that should be easy.
That was good.
All right. You need to go home.
Good chance to play with
it. All right. All right. Everybody needs to focus. Looky here. This is very important, y'all. I've seen questions like this on every state practice test, on every benchmark, on everything. We're not playing with our calculator right now. Calculator's down. Look at the screen or look at your paper. All right. This is very important. Like I said, this is on every state test, every state practice test, every benchmark has questions about this on it. So you need to know how to do it. If you pay attention, it should be fairly easy. If it's not easy to you, you need to be talking to me and asking me questions. All right? Okay. If it's in the parentheses, it's a what? X value or a Y value? X value, right? So if we're finding like f of -3, we're finding the Y value, right? Right? In the parentheses are the X values. If we're finding it, we're finding the Y value. So from a graph, y'all, we got this first graph right here, number 18. We're going to do A, B, C, and D for all of number 18. Okay? So that means we're going to find the X value where -3 is on the X. Where is that touching the graph? 1, 2, 3. It's touching the graph right there, isn't it? Y'all see that? What's that Y value? It's touching right there. The Y value is 2. And you're going to write equals 2. And that's your answer. Y'all see that? So you got to know how to read a graph, basically. Okay? So these are the X values, and you're finding the Y values. So when F is 0, so that's on the Y-axis, right? It's touching the graph up there. What's that Y value? 5. Oops. No, it's supposed to be really easy. So if you're needing help, you need to be asking. Now see what I'm doing here? Then I'm going to do, I did it backwards. I did AC. So now I'm going to B. Sorry. So 1, where's it touching the Y value? What's the Y value for the graph? It's up at 2 again. So Y values can repeat in a function, right? Yes. The X's can't. And what about F of 2? Y'all tell me.
-3, I got.
I think it's down there. I think -3. I could also see it argued to be like -2.5. Right? But we're just estimating. Do y'all see what we're doing there? We're looking at where that X value is. You're writing down the Y value. Does that make sense? Okay. Let's try number 19. We got this squiggle. Right? A curve. You're looking for the Y value.
Oh, they're solving.
You're not solving. You're looking. You're looking. Solving is when you have to plug something in. Right? We're just looking. When f is -3, when the x value is -3, what's the y value? Does that make sense? When the x value is 0, what's the y value? Okay? So in this next one, in this graph, number 19, when the x value is -4, what's the y value? 1, 2, 3, 4. It touches right there. The y value is 2. Does that make sense? All right, I'm going to go down. 0. When the x value is 0, what's the y value? 0. Goes through the origin. We'll go up and do C. When the x value is +2, what's the y value? -2. And when the x value is +5, what's the y value? -1. Is that okay with everybody? All right, good deal. No. All right, let's talk about zeros. What are zeros? Yeah, I want red now. All right. You can find zeros two ways. You can find a zero by looking at a graph, or you can find a zero algebraically. Okay? So, if you're looking at a graph, you're looking for the points where the graph crossed the x-axis. What the heck was that letter? The points where the graph crossed the x-axis. So if a question says, what is the zero of this function, and you have a graph, you're looking for the x-intercepts, basically. Okay? So that's what you do if you have a graph. If you have to do it algebraically, that means they give you an equation and no graph. It's going to be the points where f of x equals 0. Okay? Zeros have a lot of other words that you're going to hear me say this semester. Another word for zero is called a root. They're also called x-intercepts for obvious reasons, because we're looking for where they cross the x-axis. And they could also be called solutions. So when we get to quadratics in about a month or so, we're going to be talking about zeros being roots, intercepts, and solutions as well. Today we're going to use the x-intercepts form as well. Okay?
So if you factor out 2 from one number, 2 from another number, what's 2 times 2? 4, which is where you should have started. Does that make sense? So if you have a two problem like this, and you have a factor.
All right. Everybody got that copy down? Now this is going to be, if y'all can do what we just did, you're going to be fine with this. Okay? All we're doing is looking for x-intercepts. What's an x-intercept? Where it crosses the x-axis. So right here, number 1. Right here. Boom. Crossing the x-axis right there, you're just going to write x equals 2. Okay? So you're looking for the x value where your graph crosses the x-axis. It could be more than one. Yes. All right, so on number 2, we're crossing the x-axis right here and right here, correct? What are those? -2 and +1. So if there's more than one, we'll do those little brackets things. -2, 1. Not parentheses, because that would make an ordered pair. Okay, they're two separate numbers, so we do brackets. Okay. Y'all see what we're doing here? That's what we're doing? Looking at x-intercepts. Number 3, where's the x-intercept at? I believe it's at 3. So you just say x equals 3. Number 4, how many x-intercepts does it have? 2 of them. So we're going to do the little bracey things. Curly brackets, whatever you want to call it. What are they? -4, +1. Y'all agree? Easiest thing we've done all day, right? All right, number 5. How many x-intercepts do we have on number 5? 2. One right here and one right here. What are the x values? -1, +5. How many x-intercepts does number 6 have? 3 of them. There, there, and there. So what are the x-intercepts on number 3? -5, 0, 3. I like to go left to right, so as long as you list them, I don't care. So is everybody okay with finding zeros from a graph? Yes, y'all want the whole test to be that way on Friday, don't you? There'll be quite a few, but it won't be like the whole thing. It's evenly proportioned, y'all. All right, so now we're gonna do it algebraically. Algebraically, and this is actually pretty easy. To do it algebraically, 2 steps. First step, y'all got it over here to the left. Set the function equal to 0. You read my crappy handwriting. Set the function equal to 0, and then step 2 is solve for x. So like earlier when it would say f of x equals -13, we'd set the function equal to -13 and solve for x, right? If you're finding zeros of a function algebraically, you just take f of x and change it to 0. So on number 7, we'll say 0 equals 4x minus 8, and then you solve for x. Does that make sense? Where the function name is, you just plug in a 0 for the whole thing, and you solve for x. So how do we solve number 7 for x? Add 8, boom, boom, and 0 plus 8 is 8 equals 4x. How do I solve for x? Divide by 4, and x equals what? 2. So if I were to graph that, it should cross the x-axis at 2.
You just replace the fx with 0.
Yep, that's it. So I'm going to skip around because y'all are good at this. Let's do number 10. How do I find the 0 on number 10? Put 0 in for f of x, and then 2/3 x minus 6, right? And then how do I solve that for x? What do I do first? Nope, First I gotta add that 6. What's 0 plus 6? So 6 equals 2/3 x. How do I get rid of 2/3? Now I multiply both sides by the reciprocal. 3 over 2. Those cancel. Put 6 over 1. Can I reduce diagonally? That becomes a 1 and that becomes a 3. And 3 times 3 is 9. So that one's going to cross the x-axis at 9. Does that make sense? La 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 la. We ain't gonna do no squares. We ain't doing no squares. Let's do number 12. Do number 12. How do I do number 12? First I do what? Set it equal to 0 equals -2/5. Oh, my stupid pen. I gotta practice with this thing to get it to not do. See, the thing is, I do practice it during planning period, and it won't mess up. And then when I get in here and teach, it messes up. Now what? Oh, I forgot my X. Sorry. What do I do first? Y'all are ahead of me. What do I do first? Subtract 4. What's 0 minus 4? Equals negative 2/5 x. How do I get rid of negative 2/5? Negative 5 over 2 on both sides. And everything just freaking erased itself. What the devil? Okay, sorry, y'all. Negative 4 equals negative 2/5 x. Multiply by negative 5 over 2. Put it over 1. Did y'all cross cancel? The 2 and the 4. And that's going to be a positive 10. Did I get positive 10? All right. So that's how you do it algebraically. All right. Turn your graphing calculator on. Turn it on. All right. I'm going to have to come around, so we're going to have to be patient. We're going to have to be patient. I got to get my calculator. Give me a second, guys. I have a calculator as well that y'all can see. All right. Turn your calculator on. Yes. You were supposed to stop now. Go get one.
Wait, why don't we switch another part?
I'm hitting a button.
Because the lady told you it's not. Does everyone agree? Okay?
Thank
Now,
you.
the reason why I think that you can justify to say why.
All right. I'm clearing everybody's out. That's what I'm doing.
Okay.
Okay. I cannot follow direction. You got some imaginary crap in yours. Those are fancy.
GCF the first three is 3y with lead 3y minus 2.
Yeah, you got junk.
But GCF the second
So I'm saying people got old junk in theirs.
negative 2 with lead
This is plain.
3y minus 2. Be careful with that sign. And now we can write our 2 binomial factors. 3y minus 2 and 3y minus 2, which will be the quantity 3y
Whole lot's wrong, that ain't gonna work.
The all 3y minus 2 is not a difference of squares. 3 and 2 are not different squares. Here's why. Okay, so
Why is that in the
take binomial squares is not.
Alright, y'all hang with me.
The difference of squares would be.
Okay, because I just know if certain things are mashed in these, we're gonna have crazy outcomes. Explain. Yeah. This is why I don't allow people to like punch random buttons in my calculator. So if I ever see you doing this, like it causes me class time, and you will not be allowed to use one of my calculators ever again. So let me just say that. So if I'm not using my calculator in class, you don't need to be using yours. And I fixed your other one, by the way. So this is getting clean. Okay. Our temperatures. I'm almost done, y'all. Thank y'all for your patience. Yours is good. Now that don't mean that when we graph it, things won't go crazy, because sometimes they do. Okay. I think we're all good. All right. So y'all look up here. Y'all look up here. Okay. You can see my buttons look just like yours. They might not look, y'all's might not be rectangular like mine, but they're in the same position. Right? Right? Okay. Now, what we're going to do, y'all, is we're going to use the Y equals button to the left underneath the screen. Y equals. Okay? So you should have a screen that looks something like this. Yours might be color, yours might not be. Okay? Okay. Do y'all see? Now, I can't pull up both of these at the same time. Look at number 13. Y'all see number 13 on your paper? Do you see that it says f of x equals x squared minus 16? Y'all see that? Okay, we're going to type that into Y1. All right? Now, y'all look up here with me. To get the X, do you see the alpha button that's like a different color, usually green?
Yes.
Beside that button is a button with a bunch of variables. Hit it, and it should put an X there. Okay? Should put an X in your screen. Does everybody have an X? You got to be doing it with me, or you're not going to be with me, and you're going to be like, okay? 25 of us, we gotta be on top of it. All right. Now to get the square, diagonal from the 7 button, there's an X squared button. Do you see it? Hit that button, it puts you a square in there. Okay? Okay. Now some of you might still have the cursor up in the clouds. Is anybody's cursor still up in the clouds, or is it back down level? Okay. Then you're gonna hit minus. Now listen. We're not hitting this little negative down here. We're hitting the big minus that's a different color on the right, usually like a darker gray or something. Okay? Big minus 16. Now, if you haven't typed that yet, do not do anything else. If anybody does not look like mine so far, raise your hand. I'm going to come see it. Right there. And then hit minus, big minus, and 16. Everybody else good? Okay. Do you see the graph button on the far right side under the screen? Hit that button. All right, raise your hand if your graph don't look like mine. Yours might not be colored, but raise your hand if you don't have a problem. Does anybody have any extra crap in their graph besides this? Does everybody look like that? You're good, you're good, you're good, you're good.
I was about to say, my line does not look like
Aren't you telling me
well, she has a skinny one like hers looks like a square.
Is anybody's like stretched funny? Not working at all. Somebody bumped the wall?
Yeah, that's went on a few times, so.
Y'all get off the wall. Thank you. I'm sorry, Miss Hayes. I've told y'all. Don't worry about it. Somebody, if you bump the wall, it shakes her projector. Okay. I don't have time for this. Later. Okay. So, looky there. Where are our x-intercepts? -4 and +4. So on your paper for number 14 or 13, x equals -4 and +4. That's it. Okay? Let's skip around a little bit. Let's do number 18. Okay? So you're going to go back to your graphing calculator, and you're going to hit y equals again. Y equals again. Okay. And you're going to go back there, right? And you still have the last one typed in. So make sure your cursor is flashing on it, and you're going to hit clear. Your clear button's under your little keypad thing over there. Hit clear, and you should be clear again. Is everybody with me? Okay. Now, we're doing number 18, right? Now, you see how that's a negative x squared? You're not going to hit the big fat minus. This is when you're going to hit the little negative down at the bottom by the enter key. Y'all see it? Okay? So when your leading term, if your first term is negative, that's when you're going to hit that little negative. Does that make sense? All right. Now, where's the X button again? Oops, I didn't mean to hit 2. You can use the arrow over it, type over it. Where's X again? Beside the alpha button. Yep. And then the square, where's the square button? Diagonal from the 7. All right. And then it's plus 7x. Hit your x again. And then minus 10. I left my x off, didn't I? Well, that's okay. You can clear the whole thing out and start over, or you can just arrow over and type over. Okay?
I know. It just drew a line on the screen.
That's easy.
Okay, and then you hit graph. Hit graph. Let me hit graph. Y'all look like mine? Anybody's not working?
Mine ended up in the middle.
You didn't put the negative. Negative x squared.
It's not a
Okay.
Mine's in the middle of the two. I think I put mine in wrong.
You said minus 8 is minus 10. Okay, so what are my x-intercepts, y'all? 2 and 5. Okay, 2 and 5. So number 18, go right, x equals 2. Whoops, I'm trying to. Sugarfoot. X equals 2 and 5. Let's do a cube. Let's just go ahead and do 19 together. Yeah. All right. Go to y equals and hit clear. Is everybody back where I am? All right, we're doing number 19. So look at your paper. It's x to the 3rd power. Now to do x to the 3rd power, we're going to use what I call the rooftop button to put a 3rd power up there. So hit your x. I'll hit 2 x's. All right, the rooftop button is above your division key. Okay, so hit that. I call it the rooftop button. It looks like an arrow. And it puts you way up in the clouds. Y'all see that? All right, then you're going to hit your 3. And then you got to, okay, now listen. You're still up in the clouds and you're going to be typing in the clouds unless you come down. All right? So to come down, if you hit the right arrow, it should put you back level. Y'all with me? Anybody need help with that? Anybody need help with that? All right. Now, if you have an older version, if you have like a TI-83 or a non-updated 84 version, it might just leave it with the little rooftop button in there. Yeah, that's what hers is in there. Okay? That's okay. It'll still do the same thing. All right, now we finished the function. Which one are we doing? 19? So minus 5x squared plus 2x plus 8. Now look at mine before you hit graph and make sure you typed it correctly. If you don't type it correctly, it won't graph it correctly. Need help, let me know. And I think this one should have 3 x-intercepts if you hit graph. It should have 3. Do y'all know my clue on why it has 3? The highest exponent is a 3rd power. So most of the time, not always, because we have such things as called imaginary solutions, and you won't learn about those to Algebra 2. But most of the time, I know it's so cool stuff. Most of the time, whatever your highest exponent is how many x-intercepts you're going to have. Okay? I'm going to hit graph. Boom. Does y'all look like that? What are our x-intercepts? -1, 2, and 4. Very good. I want y'all to try one. Yeah, hang on. So that one is x is, what do we say, -1, 2, and 4? All right, I want y'all to try 20 and 22. If you're needing help graphing, raise your hand and let me know. need help, let me know.
So leading on is greater than 1. Very good. 8m squared minus 4m plus 6m minus 3. Alexis, how do we factor 4? Very good. With the first 2, leave the middle sign for the last 2. Make them look as easy as the first 2. Very good. 4m is the flat.
Yes, this I did. This I did. No, okay.
Yeah, y'all check them with each other. Help each other out there having trouble typing something. Because if you miss one little sign or something, typing it in, your graph is going to be off. Look here, right here. Didn't work. It don't work. It uses a lot of screen. Negative, so you have 2x squared. First one's x squared. Right.
I'm on 22.
And it's not supposed to be negative either. Clear out, start over. That's it, yeah. Do 20 and 22. If I could read it, I would do it in my own calculator, but I have to look over here on my paper because I cannot see what that says. Y equals. I'm about to lose battery. X raised to the third. When you're doing those extra exponents besides the square, make sure you get out of the clouds before you keep going typing. Me too. You didn't swear. Is that the second one? Hang on. Look at your paper because I cannot see. X raised to the fourth. X raised to the fourth. Let's do X. Minus 25X squared. Quit beating on stuff. Because it sounds like you're hitting the wall. Yeah, I'm getting 0. Yeah, that last one just looks like a bunch of lines, doesn't it? Because you can't see the curves. Yeah, I see that. So what did y'all get for number 20? Good. -5, 0, and 3. What did y'all get for 22? -2, 0, and 5. That's right. Yeah, if you look, let me type that one in. Y'all see it? It looks funky. Let me write it. X to the 4th out of it. Oh my gosh. And y'all listen, this new calculator program I just got last week, and my old one I had to double tap everything, so that's why I double everything, because I'm used to my old one. And so I'm trying to get used to it. I know. So I'm trying to not double tap. It is. It's easier, so much easier in a calculator. Squared, and then minus 50x. Did I type it correctly? All right, graph it. Yeah, y'all see that? If you have the color, you can tell for sure that blue is going through the y-axis.
But see, it's like
But pay attention to see it.
Yeah, it's pixelated. All right, so that's the end of notes for today. I'm gonna stop this. Now y'all get out your practice from yesterday,